So basically security is divided into two parts, as I told you. The people who are using the internet, the users who are using the internet, whatever the data is, that is basically divided into two different parts. One is private data and one is public data. So whenever you go for private data, that can be either divided into different segments based upon the requirement. That is either government IDs, bank account details, passwords, phone numbers, date of birth, and a number of things. Now, whenever you go for employees data, that is where we are going to use the CIA triad. We are basically going to use confidentiality, integrity, and availability. So we discussed till there, right? So to basically secure the employees, to basically secure the data, so it was completed, sir, in the last session. Yeah, I'm just giving a recall. To secure that particular data for the customers' data, we basically hire these hire security experts, and to secure the employees' data, we basically take care of the CIA triad, which is confidentiality, integrity, and availability. Now we basically completed this part. If we move forward, we also completed something about APIs, physical threats, OS threats, application threats. Now, in hacking, guys, we basically got 5 phases, as I mentioned in the last session. Information gathering is one, scanning is one, gaining access is one, maintaining access, and clearing tracks. There are basically 5 different phases of hacking. Now, whenever you go for the information gathering part, so first thing, coming to the basics of networking part, coming to the fundamentals of networking part, here we have ports and protocols. I hope everyone completed that assignment which I gave you in the second or third session whenever we are covering these ports and protocols. This is to just information about what are the ports and what are the protocols. So whenever you go for these ports and protocols, guys, here we basically have port number 443 as HTTPS. So whenever we basically discuss something about whenever you're trying to access any of the website on the internet, that is either some websites like Amazon, Flipkart, or any of the website which is using HTTPS. The difference between HTTP and HTTPS is going to be the HTTP is basically going to be it is not using the right encryption, so our data is not secured during the transportation. Now, whenever you go for HTTPS, whenever our data is getting delivered from one IP address to another IP address, that particular HTTPS has the right encryption, decryption algorithms used. So here you can see, so this is basically the HTTPS website. It will basically show the log and it is basically mention connection is secure. Now, whenever I open it and I basically go for certificate validity, so here I will have SHA-256 algorithm, which is basically encrypting my data, whatever I am sending. Now here, if I try to look at the different constraints here. So certificate policies, authority, see, SHA fingerprints. It is basically using the public key. Certificate is there, signed certificate is there, certification authority key ID is there. So this basically comes with the completely secure, you can tell, environment. Whenever you go for HTTPS, HTTPS is definitely going to be the secured one. See, here we are using SHA with RSA encryption. So whenever you go for HTTPS, they are basically going to be the secured ones. That is why we use HTTPS. Now, whenever you go for HTTPS, it is going to be followed by port number 443. Now, whenever I tell port number 443, let's imagine this is basically my laptop and I am browsing Amazon.com. So my laptop is having one IP address. From that IP address over the internet. So IP address is basically considered as the address of the device which is browsing the internet. Whenever you're browsing the internet from any device, doesn't matter mobile, doesn't matter laptop, it definitely has an IP address. So why basically we have this IP addresses? So from one IP address to another IP address, our data is getting delivered. And whenever this IP address is there, whatever the IP address is there, it basically builds a tunnel in between the, you can tell, senders and receivers point. So whenever the sender is there, whenever the receiver is there, in between there will be a tunnel formed. So this is basically going to be encrypted tunnel using different encryption algorithms. So in our case in HTTPS, we are using SHA algorithm, SHA, and which is basically using RSA encryption. So by using this, we are basically encrypting all the data which is being sent from one IP address to another IP address. That is sender to receiver. Sender to receiver part. Now over the internet, our data is being transferred. Same way, whenever you go for all the ports, they are basically 65,535 ports. And in this, only 1 to 1024 ports are basically going to be the used ports. These 1024 ports are completely predefined. Either you go for HTTP, either you go for HTTPS, either you go for SMTP, which is used for simple mail transfer protocol. So each and every protocol has a different port number. From my laptop, if I'm trying to use file transfer protocol, whatever the communication is being done, that will be done by the using port number 21. So if I'm going for HTTPS, it is going to use port number 43. So port number 43, port number 21, these are nothing but each and every particular device, each and every IP address here is having 1024 ports. In this 65,000 ports, in the 65,000, whatever predefined 1,000 ports, working ports are there. So those 1024 ports, one port will be used for each and every communication. For HTTPS, we use 443, FTP, we use 21. Like that, there are n number of ports which are basically used for different communication modes. Whenever you go for these protocols, guys, these are basically divided into two parts. One is TCP, one is UDP. Now, can anyone tell me where does TCP, UDP come under the OSI model, under which layer, guys? So TCP, UDP functioning is basically done in one of the OSI layer. So what is the OSI layer name? Transport layer. So whenever you go for this transport layer, here we are basically using TCP and UDP. So whenever you go for TCP and UDP, TCP stands for Transmission Control Protocol and UDP stands for User Datagram Protocol. So whenever you go for TCP, guys, here one thing is there, that is if I basically send hi, how are you question mark. So whenever you go for UDP part or TCP any part, so over the internet, whenever our data is being transferred, from one IP to another IP, the data in between, whenever it is being sent, it can be either jumbled, like are you, how question mark, something like that. So once it is jumbling, once it is one part is basically going to be, the data is going to be jumbled. It is not going to maintain the same frequency from sender's end to receiver's end. Second thing is whenever you go for this data here, so here any of these are basically divided into different segments. So here either how can be lost over the internet, either R can be lost over the internet, either Y can be lost over the internet. So whenever this data is being lost, so here UDP doesn't have basically the ability to bring back the data that is lost over the internet. So whatever data is in a jumbled format, whatever the data has been lost, the remaining data will be delivered to the destination. But whenever you consider TCP, it is little bit faster. So here in this, one of the main point is this TCP is basically going to be having sequencing pattern. So it is going to sequence all the data that is being transferred over the internet. Whenever I tell something about sequencing here, this sequencing is basically done. So here hi is 1, how is 2, R is 3, 4 is U, and 5 is question mark. So whenever I basically consider 1, 2, 3, 4, 5 are basically the numbers, whenever the data is jumbled, they are again going to be rejumbled in the same format. From the sender's end to receiver's end, in between whatever the data is lost, let's say how is lost here. So that packet can be again, it can be recalled by the TCP protocol. So that is the part where TCP is more reliable. TCP is, so whenever you go for the difference, UDP is unreliable protocol. There is no sequencing, there is no acknowledgement. But whenever you go for TCP, here we have, it is basically going to be reliable protocol, sequenced protocol, and also acknowledgements have been done. So whenever I tell sequencing, sequencing is basically used to bring your data in the same format to the receiver sender. So however the sender is going to send the data, the same data you're going to receive in the same format. But in UDP, you're going to be getting the data in this format. That is basically the difference between TCP and UDP. So whenever you go for ports and protocols, guys, they're divided into two different things. So TCP and UDP. So each and every port, whenever you go for 1024 ports are in use. Under this 1024, few of them rely on TCP, few of them rely on UDP. So whenever you go for this cheat sheet, there you might have observed that FTP/TCP will be there. Again, DHCP/UDP will be there. That is because they are going to use this protocol for the transportation. So whenever the transportation is being done, whenever the data is being sent from one IP address to another IP address, so that particular data, whatever it is there, it is either sent using TCP or either using the UDP. See, in this OSI model, we basically have 7 different layers. Physical layer, which basically deals with routers, hubs, ethernets and all. Data link layer is there, physical addressing, MAC address, ATM, HDP, fiber channels. Networking is there, which basically deals with IP addressing, ICMP, IP security. So transportation layer. So this is basically called as heart of OSI model. The reason why it is called heart of OSI model is because it basically joins three different hardware layers, 3 different software layers. Whenever you go for 3 different software layers and 3 different hardware layers, those are basically combined by using this transportation layer. So that is what transportation layer basically functions, how it basically functions. That is basically the use of transportation layer in the OSI model. Now guys, whenever you go for TCP, so whenever there is basically a connection between a website, okay. So here the client is going to be having one IP address. The client is basically going to be having one particularly IP address. And whenever I basically tell, this is basically one IP address, and here website server is also having one IP address. So technically telling, server is having one IP. Server is also having one IP. And whenever this, guys, anyone having the same issue with the voice? Is my voice loud and clear, guys? Give me a quick confirmation. It is clear, right? So I guess you need to check your internet connection once, Kiran Kumar. Just check your internet connection. So guys, whenever we basically speak about transporting the data from, whenever the data is being delivered from the client to sender to the receiver's part. So here sender is going to be the client, that is basically having one IP address, and receiver is basically going to be the server. So here the destination is basically the website. So can anyone tell me, whenever you go for the website, technically how can we address a website? So whenever I am sending a request, okay, whenever I'm typing something, so how, whatever I type on my Google or any of the search engine, any of my preferred search engine, whenever I basically type something, how am I going to locate that address? How am I going to locate that website? In the backend, what is the technical part that is going to resolve that? You can tell company's name or website's name. So each and every basically website is having a name, right? So whenever you type that name, you're going to get the website. So under the back end, there is basically one thing which will try to help us to find it over the internet. What is that? It is related to company's name. See guys, whenever I type Amazon, okay. So whenever I type Amazon, my request is going to Amazon. I will be able to look at the portal that Amazon website is open, okay, on my laptop screen. But in the backend, what is happening exactly? So here in the backend, you have server which is resolving our request. After server basically resolves our request, where does this server forward our request? Can you tell me, guys? It is basically something working in the website's backend which is resolving our request. What is it? See guys, whenever you are trying to work on a website, whenever you're searching for one website, if I basically search Amazon.com, okay, how am I going to reach Amazon.com exactly? What is happening in the backend? There is one technical name related to website's name. What is it? So, okay, let's keep it like this. Whenever you want to host a website, how are you going to buy a name? If you want to host a website over the internet, how are you going to buy a name on the internet? Guys, I guess you all forgot whatever I thought here. There is something. See, whenever you go for company's name, either it is Amazon, Flipkart, or whatever it is. So, what is that Amazon.com, Flipkart.com technically called? Domain name. So, it took this much time for you guys to think what exactly resolves the backend whenever address, how basically the address is resolved over the internet. So whenever you go for client is going to have an IP address. So whenever you basically browse the domain name, right? Amazon.com is basically the domain name. So that particular DNS server is going to resolve the name over the internet. And then this server is going to find that domain name here. The domain name is basically found by the server. Now over the internet, so whenever you go for a client is going to send a request. That particular request is basically whatever the request is that is resolved by the server. That server is going to forward that request to the domain name. That is basically whatever you type to the domain name. It is going to search that domain name over the internet, and that particular request is being forwarded over the internet to the domain name. This is basically what happens in the backend. Now, whenever you go for client IP address trying to request the server to basically connect, what exactly happens is whenever you go for client IP address, that is, let's say this is my own laptop, I type Amazon.com. Whenever I type Amazon.com, basically my IP address is going to send a SYN, that is basically synchronized flag first. It is going to send a synchronized flag. Now, what is this synchronized flag used for? Synchronized flag is basically used to initialize the connection. Whenever I tell initializing the connection, how it is going to initialize the connection? So whenever you send this synchronized flag to the server, you will basically get to know whether the server is live or it is basically offline. So whenever I tell live, it is basically represented as online or offline. So let's say the server is online and it is in a good state that it can basically process the requests. Sometimes what will happen, if the server capacity is, let's say, 10,000 requests, and there are 1 lakh to 2 lakh requests which are being sent to the server will stop working. That time you will send synchronized flag, that is basically which is responsible to initialize the connection. You will send a synchronized flag, but from the server you will not receive any acknowledgement. So let's say server is live and it is in the live position, it is online, that it is in a position that it can process our request over the internet to the website, and it can make the help us build the connection between client and the website. So in my laptop, I can browse Amazon.com or Flipkart.com, anything. Now in between here, whenever we are basically trying to build a connection between a domain name and a client IP address, what is exactly happening is, first we will basically send synchronize flag. This synchronize flag will let us know whether the server is online or offline. If the server is online, then it is going to send back another request. We are going to receive our synchronized request, plus also we are going to receive the acknowledgement that, okay, I am still online, I can work. Then it is going to send the acknowledgement. It is going to confirm that I am working. So if you want to basically know whether the server is live or not, first we are sending synchronize, then we are receiving synchronize plus acknowledgement. So we can predict that server is online, it can basically work. It will basically confirm that I am online. Once the acknowledgement flag is received, then it is basically confirmed that the server is online. It is in the functioning mode. After that, we will again send the acknowledgement. We will again reconfirm. We will basically again send the acknowledgement flag. The reason of sending this acknowledgement flag again is that I am establishing the connection. Once this acknowledgement flag is received by the server, then the connection will be successfully established. Now this synchronize is being sent, we are get to know, so synchronize is being sent, we are getting to know that server is online in the functioning mode by receiving the synchronize and acknowledgement flag from the server. After that, we are also sending the acknowledgement that, okay, I am ready to build the connection, and connection is built. Now this particular process is basically called as it is basically called as three-way handshake. Now, whenever you're trying to basically build a connection, whenever you're trying to transport a data between client and server, that particular request, whatever is there. So to build the connection between the domain or server, that basically connection should be established by three-way handshake itself. So in TCP, it is used by TCP to establish a connection between client and the server. So whenever you're using synchronize plus acknowledgement and acknowledgement, it is confirmed that you build the connection. Then after that, you will start transferring the data. So whatever your request is there, that time it is going to send to the server. It is going to resolve your IP address. It is going to resolve the request. It is going to find the domain name of the website. Then it is going to forward your request over the internet to the website. That time you are going to get the Amazon.com or desired domain name, whatever website is there, that will be displayed on your browser. This is exactly what happens in the backend. Now, whenever you go for TCP, here synchronize, acknowledgement. These are basically considered as flags. Flags are nothing but, here they are basically 6 different flags, guys. So first flag, synchronize. It is basically responsible to initialize the connection. So starting stage, whenever you want to build the connection, that time you will send synchronize. Next, second one is going to be acknowledgement. Acknowledgement is nothing but the confirmation flag. Whenever you receive the acknowledgement, you will basically be sure that the connection can be built here. You will also send the acknowledgement and the connection will be built. Third one is fin flag. Fin flag is nothing but finish flag. So finish flag is basically used to terminate the session. Whenever you want to terminate the session, you are going to use this finish flag. Now we got something called as reset flag. Reset flag is nothing but to reset any of the connection. If you basically are connected, you are connected, the connection is good, the connection is live, and you want to reset the whole connection, that time you are going to send the reset flag. Push flag is there. Push flag is nothing but whatever the buffering data is there. Buffering data in the sense, if we take an example of a normal online, if you're watching a video, so the video basically, if the internet is not good, if you don't have the good internet connection, if the internet connection is weak or it is getting fluctuated from 1 MB per second to 10 MB per second to 20 MB per second. So sometimes it is getting down, sometimes it is getting good, you can tell MB per second. So that time what will exactly happen is, so whatever your video you're watching, first it will take 10 seconds to load, right? That loading time is basically called as buffering time. So during that buffering time, it will basically collect the data for the next 1 minute or 2 minutes. Then continuously it will play for 2 minutes over the internet. Same thing whenever you go for push flag also, whenever there is some kind of buffering data over the network, it is going to collect some data. After that, it is going to send the data. That is basically how push flag works on the buffering mechanism. Now, last one, we got urgent flag. So whenever you go for urgent flag to prioritize any work in the connection. Now, if you take an example in urgent flag, so if you basically are working on, let's say, take an example of alarm, or any of the Skype meeting is there, or Zoom meeting is there. So whenever you go for the Zoom meeting is basically scheduled for 6 o'clock, let's say 6 o'clock. And on 5:59 to 6 o'clock, if you basically keep an alarm or anything, that time you're basically going to get the alarm ringed, or you're going to get the reminder, or basically you're directly going to join the meeting. So in that way, whatever the urgency work are there, whatever the required urgent data should be transferred at that some period of time, exact time, then basically you will be using the urgent flag to prioritize any work in the connection. So rather than whatever the connections are there, those all connections are basically put aside. They'll basically kept aside, and then you will basically build a connection between that. Urgent flag will be sent. Then whatever the urgent flag, whenever the urgent flag is being sent, it will basically prioritize the connection. It will break all the connections, and it will build the connection with the particular IP address. So that is basically where we use urgent flag. So these are basically 6 different flags, guys. So till here, anyone having any doubts, guys? Till here, any doubts, anyone? Quick confirmation, guys, whether the topic is clear, everyone. Okay, let's move forward. So, okay, this is not the time. Now, we basically got something called as network topologies. So whenever you go for network topologies, as I already told you, we got 7 network topologies. Point-to-point topology is there, mesh topology is there, star topology, bus topology, tree topology, and hybrid topology. So under this topologies, guys, so what is exactly a topology? Whenever you go for a topology, so it is basically whenever you want to build a connection, so build a connection between 2 different components. So to make that connection, to make the communication between 2 different components, let's assume that A is basically one component, B is basically one component. You want to build a connection, communication between these two. So I want that A should communicate with B, B should communicate with A. So that basically topology, whatever is there. So that topology will help these A and B components to communicate between 2 people. So here it is a way that defines the structure of communication between the components connected to each other. So whatever the components are connected to each other, for the communication purpose between the 2 components, 2 different components, we are using topologies. So under these topologies, we got 7 different categories. Whenever you go for point-to-point topologies, point-to-point topologies is one of the simplest topology, which is one is basically going to be the sender, one is going to be the receiver. Now we basically will communicate with 2 different nodes. One is sender node, one is receiver node, which basically will provide the high bandwidth. This is the most simple one. So one-to-one communication will be there. Now, if you go for mesh topology, so here whatever the devices are there, 5 devices are there, 10 devices are there. So exactly what will happen is this one particular device can communicate with 4 different devices. This particular device can communicate with other 4. This can communicate with this 4. So here, whatever the connection is there, it is basically oriented towards one particular component, one particular device can be connected to all the 4 different devices. Whenever it want, it can communicate to all the devices which are connected to this device. So how the connection is built? It is basically built from this device to these 4 devices. Again, this device to these 4 devices. So one device remaining all devices, one device remaining all device, one device remaining all device. In that way, the connection is basically built. Now, star topology is there. Whenever you go for star topology, Here we got something called as hub. Whenever you go for hub, here we have 4 different components, A, B, C, D. Now, these devices are basically connected to one central hub. What is this central hub is doing here is, whenever it basically gets something from A it basically transfer the data, whatever it wants to communicate with B. A will send the data to hub, hub will send the data to B. If B wants to send the data to either C or either D here, B will send it to hub, and again hub will basically send it to D. Like that, hub is basically going to work as a central node for all the different devices to communicate. Now, whenever I basically tell hub is basically responsible in between here to build a connection. So here there is one drawback, right? What is the drawback is, so if the hub stops working, then there is no communication between A, B, C, D. That is basically one drawback in star topology. So here in star topology, exactly what happens? If this central node is not working, then there is no communication between A to B, B to C, C to D, or any of the devices connected to the hub. That is how star topology works. Now, we got something called as bus topology. So under bus topology, here what will exactly happen is, there is basically a network type. So here we got something called as backbone coaxial cable. This basically backbone coaxial cable. This is basically one single cable connected to multiple devices in a bus. So here, whenever you go for this one single cable, backbone coaxial cable, it is connected to 4 different devices. So this is basically going to be the starting point. This is going to be the termination point. Termination point. Whenever basically here, from here the connection has been started. So here, whenever this particular device wants to send the connection to communicate with this particular device, here it should basically pass through the coaxial cable and then reach to the another device. So receiver is there, sender is there. But here also one drawback is, whenever this basically coaxial cable damages, or whenever this single node, which is basically being used for the communication, if it is getting damaged, then there is no other communication part for them to communicate. That is the main thing. So it is a network type in which computer and network device is connected to a single cable. So one single cable, multiple devices. So if one single cable gets damaged, then there is no communication source between all the devices. So this is basically of higher cost, and also one drawback is, if the cable fails, then the whole bus topology, whatever is there, there is no communication between any node. Ring topology is there. So under ring topology, guys, here we got something called as repeaters. So whenever you go for the devices 1, 2, 3, 4, 1, 2, 3, 4 are there. So it basically forms a ring here. So here internally, there are basically different 4 repeaters. 4 repeaters are there. So whenever they want to communicate, so this particular one is there, one will send the data to this repeater, and this repeater, if you want to basically communicate with 4. So let's say one wants to communicate with 4th device connected to the topology. So one will send a communication part to the repeater. So what these repeaters will do, this repeater will try to go in a anti-clockwise direction. So it can't directly go from 1 to 4. It will go from 1 to 2, 2 to 3, 3 to 4, like that. If you want to communicate with 3, 1 and 3 wants to communicate, then this message communication mode, whatever is there, that communication need to be passed from 1 to 2, 2 to 3, like that. So this is basically a lot of here there is time duration will be more. And one more thing here, one of the you can tell advantage, there is one advantage, one disadvantage. Whenever you go for one advantage, you basically need to communicate in the anti-clockwise direction itself. And one the advantage is, here we got something called as repeaters. These repeaters basically help you to save your data from the data loss. Here you are preventing the data loss by using these repeaters. So the main responsibility of the repeaters is to save the data loss. So prevent the data loss. That is why these repeaters are being used. Now we got something called as tree topology. Tree topology is, guys, nothing but here also we basically got central hub, secondary hub, and again there are basically different devices connected. Now here what we are going to use is, here each and every hub will have a number of devices. Now if you want to basically extend this, you are going to connect to another hub. See, central hub is there. Central hub is connected to two devices. Now if you basically want to again add more devices, you can going to connect again, secondary hub can be connected to this secondary hub. We are again connecting number of devices. If you want more 10 devices, again we are going to call the third hub, again fourth hub, again fifth hub. Like that in tree topology, it is basically whatever the architecture is there here. So using this tree topology, whenever you go for it, starts from the central hub. From the central hub, the hub will be sent to secondary hub. Again, third hub could be called, fourth hub would be called, fifth hub, sixth hub. Like that, each and every hub will have a number of devices. So whenever you go for the communication part here, again, three needs to send the communication, three needs to send the message to secondary hub. Secondary hub will transfer to the destination. So in between, hub is going to be the mediator. So here also, whenever you go for this topology, the star topology, here we got hub. So A needs to send the data to D, or A needs to send the data, communicate with B. Whenever A wants to build a communication with B, so it need to interact with the hub first. The whatever the data is that is sent to hub will transfer it to B, from A to B, like that connection is there. Same thing here also in tree topology. Whenever 3 wants to communicate with 5, it should communicate via secondary hub. It can't directly communicate. There is no direct communication part. It needs to communicate first to secondary hub, then secondary hub will send the data to the fifth one. So that is basically how it is. So here one thing is, this basically starts from the central hub, which is the top one, and it can move towards the bottom. So various secondary hubs can be connected to the central hub, which contains repeaters, and also the data flows from top to bottom. That is tree topology. Hybrid topology is nothing but, guys, in hybrid topology, we are going to use the combination of topologies. Either you can use star topology and bus topology, or mesh topology, star topology, like that. So using multiple topologies, what will exactly happen? The size of network, whatever is there, the size of devices which can be connected, those devices are basically, they can be doubled, or you can add a number of new devices, first thing. And also, if one topology fails, you can basically use another topology for the communication part. So using multiple topologies will basically reduce the risk of getting losing the connection between the devices. So that is why we use the hybrid topology. Just a moment, guys. Now here we discussed something about IP addresses, how exactly the IP address is being defined, what is the mechanism. So here, whenever your internet device is there, whatever your internet device is there, if you basically need an IP address, so on the internet, if you want your device to access the internet, you definitely need to have an IP address. So now, from where are we getting this IP address? Guys, can anyone tell me from where do we get the IP address allocated to our device? Who is allocating the IP addresses to our device? So whenever a new device is connected to the internet, it is basically having an IP address, right? How are we getting that IP address? Can anyone tell me? DHCP. So whenever you go for a DHCP, guys, dynamic host configuration protocol. So how exactly this dynamic host configuration protocol works? Let me just tell you. Here, first thing, whatever the IP addresses, CCTVs, either tabs, laptops, mobile phones, each and every device which is connected over the internet basically needs a IP address. Now, whenever you want a IP address, whenever a new device is getting connected to an internet, that time this particular device over the internet, it is going to connect to the, just a second guys, just a moment. Hello. Guys, sorry to keep you waiting. Yeah. So, guys, here, whenever you go for the IP addressing part, now how exactly dynamic host configuration protocol is able to allocate an IP address to a new device or whichever the device is connected to a network? How exactly that mechanism happens? So this is basically one of the important part in networking you need to know. So let me just tell you. So whenever you go for a client and whenever you go for a DHCP is basically a server, guys. This server, what is the exact functioning of the server? The exact functioning of the server is you receive a request, you try to resolve the request, and you try to reply it back. That is basically how the server works. Now, DHCP is also a server. DHCP also gets a request. DHCP is also going to give you a reply for the server. Now, what is the request it is getting? What is the reply it is giving? And what is how the IP address is getting generated? Let's discuss. Now, in step one, here we have uh, here basically we have one client, that is basically my laptop or any of the laptop or any of the device which wants to connect over the internet. Now what will exactly this device do is it will basically first in DHCP it will basically send a discover packet, is basically sent to the server. So whenever it basically sends the discover packet, so exactly what will happen is DHCP server will get to know that, okay, there is one device which is discovering the DHCP server to get the IP address. The reason why I am sending the DHCP discover packet is because I want the IP address to connect to the internet. So it is important that I should have an address to connect to the internet. So once I basically send a DHCP discover packet to the server, then server is going to reply me. How it is going to reply me? So here, if I send the discover packet, it is definitely getting to know that, okay, this guy needs an IP address. Let me offer him one IP address. So DHCP, what it is going to do? It is going to reply to the client with one DHCP offer packets which containing the IP address. So one packet is basically sent which is containing the IP address to the client. So here I am sending the discover packet. Here I am receiving the IP address packet. Now, once the device is going to receive, once the device is going to receive the IP address offer, what it is going to do? Then the client receives the IP address, it is going to validate the offer and it is going to send back the request packet to server. Why it is going to send the request packet is because it is sending the request packet to accept this IP address offered by the DHCP. So we are going to send a discover packet first to the DHCP server. So that DHCP server is getting to know that this guy needs an IP address. Then it is going to send the IP address in the offer. it is going to offer us the IP address. We are going to accept the IP address. How we are going to accept the IP address? We are going to send the request packet to the DHCP. Once the request packet is sent back to the DHCP to accept the IP address, so DHCP is going to say that, okay, client has accepted the IP address request. Now I am going to acknowledge. Now DHCP is going to send the acknowledgement packet to the client to confirm the chosen IP address. Now, whenever it sends the acknowledgement packet, that acknowledgement packet is delivered to the IP address which is allotted to the client. That time it is proven that this client has basically gained the IP address successfully. So DHCP work is done. Now, secondary part, whenever DHCP server is allocating an IP address to one device, it is going to lease that IP address for some period of time. So if you basically are not using that IP address, you are not connected to internet for some period of time, that IP address could be leased to another device also. So here guys, let me just show you. Just a moment. Okay. So whenever you go for this DHCP, the whole process. So here, whenever we go for home network, the router is going to work as the DHCP server. Whenever you go for router in home network, it is basically used for the allocation of the IP address. Whenever you go for the corporate network, that is either TCS, Capgemini, or any of the company's network, that company's corporate network has basically DHCP server. So that DHCP server in corporate network is used for allocation of IP addresses. So both are different. In corporate network, we have DHCP server. In our home networks, we have routers which function as a DHCP server. So routers are only responsible to give the IP addresses. Now we'll just go for the part 2. So I guess everyone know what is the functioning of firewalls, guys. I hope everyone know what is the functioning of firewall. So here, whenever you go for firewall, can anyone tell me on what does firewall operate exactly on? Guys, whenever you go for firewalls, they basically are going to protect your infrastructure, protect your laptops, protect your connected devices to the network. So how are they trying to protect? Who is guiding them? And how basically they are trying to define whether the network is a fake network or fake or legitimate network which is trying to access the server inside. So let's take an example. Here client is there, here server is there, here database is there. Okay. So whenever client is sending a request to the server, if the IP address is genuine and it is basically requesting for the legit request which is allowed for the public access, then firewall is going to allow that request and go to the server. But if client is basically requesting to the private files, which is not the public data, it is completely private data, or the IP address is fake, or it is using some kind of proxy or something, then it is going to cancel the request. It is going to block that particular request, and it is not going to allow that request to connect to the whole network, whatever network is there. It is not going to allow that particular request to get into the network. Now, can anyone tell me on which basis are we trying to basically are we trying to differentiate between legit network access, legit request, and fake request, guys? Can anyone tell me how we are basically predicting here? Whether, let's say if there is some fake IP address, firewall is going to block the request. If it is a legitimate IP address, it is going to accept the request. Now, how it is trying to block, how it is trying to allow the IP address to access to get connected to the network. Guys, on what basis are we trying to define whether the IP address to allow the IP address or to deny the IP address? See guys, IDS and IPS are basically going to be the types of firewalls you can tell. But here, whenever you go for this firewalls here, exactly what will happen is, this firewall is basically going to have something called as rules. This firewall is basically containing some rules. And also, we also call them as rule sets here. So here, what are we going to define in these rules? Here, under these rules and rule sets, we are going to give the firewall few rules, few, you can tell the data, few fake IP addresses, few legitimate IP addresses, or you want to basically allow only your employees. Let's say your employee count is some 100 employees are there in an office. So let's say in one office, there are basically some 100 employees. So whenever we tell 100 employees are there, I am going to give 100 IP address, 100 IP addresses to this particular firewall, under rules. So I will just add a rule that allow this 100 IP addresses, block the remaining IP addresses which are trying to access the server or else the database. That is basically the rule which I'm trying to give. Now, whenever you go for this rule, guys, whenever you go for this particular rule sets, they are basically defined to filter the traffic. So how we are going to filter the traffic is, here we got two types of traffic here. One is going to be inbound traffic, one is going to be outbound traffic. So what is exactly inbound? What is exactly outbound? So here, yeah, here I basically explained. See, here let's imagine that these are basically different computers, different IP addresses who are going to try to access the server, who are basically trying to access the database. My target is to access one file from the database. So what I'm going to do is, I am going to send a request to the server first. Server is going to take my request, it is going to process and it is going to forward the request to the database. And then from the database, I will download the file, upload the file, or I will do changes. Now here, whenever these firewalls are there, they basically try to allow the IP address to access on based upon the rules. And here we got something called as inbound and outbound traffic. So inbound is nothing but whatever the traffic is coming from outside. So this is basically inside, guys. This box, whatever you see here, this is basically the internal network part. The private network also you can tell, you can also call it as an internal network. So here, the traffic which is coming from outside to inside, that is basically the internal network. The traffic which is going from internal network to outside the network, that is basically outbound traffic. So this is inbound traffic which is trying to connect to server database. So whatever the traffic is going outside, that is outbound traffic. So here, whenever I tell inbound and outbound traffic, so the best example is whenever you go for this corporate TCS, Capgemini, or Wipro, Infosys, any of the companies, they basically have separate laptop for office work. In that laptop, you can't browse YouTube, you can't browse any of the other content. Okay, on office network. Not only those devices, if you go connect to any of the office Wi-Fi, few office Wi-Fi's are basically defined that you can't access social media, you can't access the YouTube, you can't access few websites on that network. There is basically different network to personally use, but whenever you go for professional network, by using that internet network, your basic internet connection, you are basically communicating with clients, you're communicating with the production team, you're communicating with work. So whatever your communication is, that is based upon one network. So that on that network, they will try to define that YouTube, Instagram, these all different, they basically are not going to allow you for the access. So whenever I tell they are not going to allow you for the access is, what they are going to do is, here, let's say this is basically some kind of TCS company. Let's take an example of TCS company. So this is basically TCS company's internal network. Okay, this is basically the office network. Now, whenever you go for this office network, inside I have one laptop, two laptops are there, which are connected to this network. Sir, IP address is always always changes no, then how the firewall gives the access to our IP. So it is basically like whenever you're sending a request, based upon that request basis, it is going to allocate. So whenever I tell something about the TCS, Capgemini, or any of the companies' laptops, they are basically defined, the rules are basically sent over the device. Whenever you're going to send the request, that request is going to be accepted by the firewall. See here, one more thing is, here I am telling about a legit IP address and fake IP addresses. So one thing to confirm, guys, legit IP address is legit IP address is nothing but the IP address which is not using any kind of proxy, or it is not using any kind of tool which is trying to hide the IP address. So the user who is going to hide the IP address, then that user definitely will not get the access. The user who is genuine IP address is there, that user is definitely going to get the IP address, going to get the access. That IP address is going to get the access. So here, whenever you go for TCS company internal network, so here I basically have two laptops in TCS company's internal network. So here in this laptop, if I try to browse YouTube, okay, if I try to browse YouTube, or if I want to basically browse some website which is using HTTP, not HTTPS, guys, HTTP, which is basically using HTTP protocol, which is completely not secure. So I am trying to type on Google some website which is using HTTP. So that is basically going to be the outbound traffic. The traffic will pass through the firewall. So firewall is basically going to be the gateway for inbound traffic and outbound traffic. So whenever I'm browsing such things, firewall is going to not allow that connection to be established. Now again, from outside also someone is trying to insecurely access the server and database. There also firewall is not going to initiate the connection between the database or server. So if the connection is secured, then it is going to allow you. If the connection is not secure, it is going to deny the request. It is going to block that particular connection. So that is basically how firewall works. Here, one more thing. Whenever an IP address is basically allowed from the firewall, and firewall, what it is going to do, it is going to store that IP address. So whenever there is, let's say, there is one device, this one device IP address is there, some 192.168.2.8 something. So whenever this IP address tries to communicate with the server or database, here, one thing is that whenever there is a public private network, you are going to get something as login page password, employees login, employee password to connect to the private internet network of the company. Definitely, you need to have the credentials authorized by the TCS company to access over the private network where all the production work is being done. Second thing is, if you also want to communicate, if you also want to build a connection with public network, which is basically used by the TCS employees to browse YouTube and all with their personal laptops or mobile phones, that particular network, public network, if you want to connect to that public Wi-Fi also, once you basically build, so that time firewall is going to allow you to connect to the public Wi-Fi. If you basically connect to the public Wi-Fi, what exactly will happen is this firewall is going to store that IP addresses. In one table, it is going to store the IP address, and it is going to monitor what you are doing in the network. You are accessing server, you are accessing database. What are you doing? Here, there are basically rules in firewall, right? Under these rules, I will keep one rule that no one can download the data from the database which is greater than 1 GB. And no one can upload the data which is greater than 500 MB. So I'll basically keep some kind of limit. Now, if some person is there who basically try to access the network and he is trying to download all the data from the database, he is trying to download the company files, whatever are there. So that time I'm going to basically block that IP address, block the request. So that is basically how firewall going to deal. Now, whenever it is storing the IP address here in the table, so it is going to monitor what is this IP address accessing. Whether the IP address is accessing some folder in the database, it is trying to upload the data, it is trying to download the data, it is just reading, it is just writing, editing. Whatever is being done under the internal network, not only database, not only server, whatever devices are there, if this IP address is basically trying to look for something which this person is not authorized of, then particularly this IP address request will be blocked at the same time. So he will be kicked out of the network automatically. Again, if he tries to build the connection, the firewall will block the connection. So based upon what you do in the network also is being monitored. Once you firewall allows you to get into the network, if you do something that is not accepted, then it is going to block. That is one rule. And also if you are basically using some proxies, then the request is going to get blocked. If you try to access to the private network and you get some login page that is authorized by the TCS company, and you're trying to bypass this login page and you're trying to get the access, then also firewall is going to block your request. So like that, there are n number of different number of rules, guys, to basically use in firewalls, either on networking, outbound traffic, inbound traffic, database rules, server rules. Like this, one firewall is responsible to secure the whole internal network of a corporate company. So that is how firewall is basically responsible of. Now, under firewall, we got two types. One is basically going to be intrusion detection system. Other one is going to be intrusion prevention system. Now, intrusion detection system is nothing but whenever, so basically what is intrusion detection system? Under IDS, what basically stands for I? I is nothing but intruder, guys. So who is going to be the intruder? The person who is going to try to get some unauthorized access and try to jump into our network. That is basically the person who is intruder, who tries to get in with unauthorized access. So to detect these kind of intruders, this type of unauthorized IP addresses, we are having intrusion detection system and intrusion prevention system. Two systems are there. So whenever you go for intrusion detection system, whatever rules we set, whatever n number of limitations we basically try to maintain, based upon that, if someone tries to get some unauthorized access, then this particular intrusion detection system is going to detect that intrusion, and it is going to send an alert, or it is going to basically, it is going to either alert or it is going to release a threat to the internal admin portal. So whenever you go for IDS, IPS, so in one network, we basically got something called as monitoring system will be there. So whenever you go for a network, guys, so each and every network, just a moment. So in each and every network, there will be something called as network monitoring systems. So whenever you go for this network monitoring system, the whole network here, the whole network will be monitored. Now, who will basically be monitoring this network? Either they are basically cyber security team, or either network operation center, security operation center will be there. So this security operation center, network operation center, these people will have, these people's day-to-day duty, day-to-day work is to monitor all the IP addresses which are connected over the internet. Now, whenever this IDS basically detects the intrusion, it is going to send an alert to the network monitoring team. So network monitoring team will basically be handling the firewalls and IDS and IPS. They will get an alert. Once the admin basically gets an alert, he is going to decide either it is some kind of false positive, or it is kind of some kind of you can tell serious action to be taken on that particular IP address. If there is something unauthorized, then he is going to block the IP address and blacklist the IP address. If there is some kind of false positive, some legit IP address is only trying to do something and still it is getting the alert is being generated, then definitely the admin is going to accept that particular request. So IDS is basically determined to detect and alert. That is the only thing that IDS can do. Intrusion detection system. Whenever you go for IPS, intrusion prevention system is there. Whenever you go for intrusion prevention system, guys, intrusion prevention system is basically going to directly block the access of the intruder. How exactly it is going to directly block the intrusion, access of the intruder is same thing. whenever the firewall is there, whenever the firewall is basically monitoring the IP address, whatever he is doing in the whole infrastructure here, whatever is downloaded, whatever his one IP address is uploading, whatever the actions are being done by that IP address under the internal network, those are being monitored, right? During the monitor, whatever the monitoring is being done, during the monitoring, if there is something that some unauthorized thing is being done, that time directly this intrusion prevention system will block the IP address. rather than generating alert, rather than generating any kind of alert to the admin, it is directly going to block that particular IP address. Here, IDS is going to detect and it is going to just basically trying to alert the admin, but IPS is going to directly block the intruder's access. So the IP address is directly blocked and blacklisted at the same time. Just a moment, guys. Just give me 1 second, guys. I'll be back. Yeah, guys. So in firewalls, how to do projects, sir? Sir, can you explain about our project? Guys, whenever you go for projects, you will get the right guidance. Don't worry. Uh, in the next session, I'll just let you know how to do your projects. So I guess everyone received your projects, right? You have some kind of, you can search on GitHub, you can search on different online materials is available whenever you go for those projects. Who is this? Yes, regarding projects, you will have information. So just give me some time. In next session, I'll just let you know about the projects. So guys, right now we were basically discussing about types of firewalls, right? So in types of firewalls, guys, we got three types: packet filtering firewall, stateful inspection firewall, proxy firewall, application firewall. So whenever you go for these four types of firewalls are there. So here, whenever you go for packet filtering firewall, so uh, each and every firewall basically works on one mechanism, that is basically logs. So if you basically log in, log out, download, upload, or try to build a connection, try to break the connection, or whatever activity is there, those activities are basically defined as logs. So these logs will be generated each and every time you try to do something on the network. So whenever you try to perform something, whenever you try to do something, you will have something called as logs being generated. So these firewalls basically will be also these firewalls basically will be monitoring those logs. So whenever you're trying to monitor those logs, so based upon packet filtering or any firewall is there, they are basically going to work on only one scenario, that is monitoring the logs. By monitoring the logs only, the rules will be implemented. The admin will get the detection alerts, and prevention system is also going to prevent the access. So whenever I tell firewall is basically going to monitor all your actions. So it is going to monitor all the actions based upon only one thing, that is what are you performing over the internet, what are you performing over the internal network. Under internal network, whatever you're downloading, uploading, so whenever the logs are being generated, those logs are basically being monitored by the firewall itself. So on that basis, firewall is basically going to know to block your access or to allow you to access all the resources. So here, packet filtering firewall is there. Whenever you go for packet filtering firewall, it is intended towards the networking part. So it basically examines the packets which are basically defined. Either it is some kind of inbound rules, inbound traffic, outbound traffic. As I told you, inbound traffic is basically the traffic which is coming over from outside, which is trying to access the private network of the organization. So this is basically inbound traffic, and this is basically outbound traffic, which is going outside the network. So two types of traffic is there. Packet filtering traffic basically examines the packets, whatever are being sent, either it is inbound, either it is outbound. So that packets of data which pass through the network and allows or blocks the access based upon the defined rules. So packet filtering firewall is defined over the basically networking part. Now it basically operates on layer 3. Now whenever you go for the, we basically speak about the advantages. It is definitely simple and efficient. And also whenever you go for the networking part, it has a good performance because each and every packet in packet filtering firewall, each and every packet is examined properly, and then the packet of data will be either accepted in the internal network or be blocked. So each and every packet of data will be examined properly. The only disadvantage is because, see, here whenever you're trying to send the data, right? Whenever the client is basically trying to send the data, if each and every packet is being examined, that time exactly what will happen is it will take a lot of time for the examination part itself. So one packet will be sent over the will be allowed in the private network. So whenever it is accepting each and every packet, examining and accepting, examining and accepting, examining, accepting, that time it will take lot of time. So for that, we basically call something called as latency issue. Latency is nothing but, guys, something related to speed, you can tell. May face latency issues because the packet tracking. So whenever it tries to track each and every packet, definitely the whatever the functionality is there, whatever the performance is there, that will be little bit slow will be there. So whenever something impacts on the performance and it is not going to perform to the proper manner, that time we basically call it as a latency issue. That is basically speed issue, you can tell. Now we got something called as proxy. Under proxy firewall, what will happen, guys? Here under proxy firewall, here we got something called as external server. So what exactly external server will do is it will basically act as an intermediate between client and the server. So here exactly what will happen, client will send a request, firewall is going to forward the data to the external server, then again it is going to forward it to the database. So whenever the external server is there, what will happen is whenever the external server is there, the risk whatever should be faced by the internal network, that risk will be faced by the external server itself. If there is something harmful to happen, this server will face it, but not the internal network. So that is why whenever we use proxy firewall, we will create a proxy server. So whatever the requests are being sent, those will be forwarded to the proxy server. Once the proxy server firewall basically tries to examine each and every packet and everything, then it is going to allow that to access the internal network. So here we got external server that is going to act as an intermediary between client and server. It is going to intercept the traffic and evaluate the traffic on behalf of the client. That is proxy firewall. Now stateful inspection firewall is there. Now whenever you go for stateful inspection, guys, it basically maintains the information about all the active connections. So whenever I tell active connections, here basically I have 4 different clients, right? So I basically have 4 active connections. So these 4 active connections, how many connections are there? How many connections are live connected to the internal network? That is basically maintained by the stateful inspection firewall. Now it is going to monitor the successful TCP handshakes. TCP handshakes in the sense, when are we basically going to use TCP handshake? We use TCP handshake only when we want to build the connection. So TCP handshake, once a TCP handshake synchronized plus acknowledgement and acknowledgement is implemented properly, then definitely we are going to think that the session has been established. The session has been established and whatever the packets are there, they are being transferred from one IP address to another IP address. So monitoring those sessions, monitoring the packets information and monitoring the TCP handshakes is basically duty of stateful inspection firewall. So the advantages are nothing but it basically provides a better security when compared to packet filtering firewall, because packet filtering firewall only concentrates on tracking the packets and checking the packets. But whenever you go for stateful inspection firewall, it basically is monitoring TCP handshakes. It is basically monitoring the sessions information in the sense what sessions have been successfully established, what sessions have been basically not able to establish the connection between client and the server, and what are the packets, what is the data being transferred between after the session has been established. So each and everything is being completely monitored. So here only one disadvantage is that the latency issue. This might also be little bit slow, not latency issue in the sense, guys, it is like just some 2 to 3% of you can tell performance will be degraded. That's it. So I guess we discussed about IDS. Under IDS, guys, we got network-based intrusion detection, host-based intrusion detection. So network-based intrusion detection system basically monitors the traffic, which basically it monitors the traffic. In network traffic, we got packets which basically be transferred from one point to another point. The packets will be shared, right? Whatever the data is being transferred, that is transferred in the form of packets itself. So those packets are being monitored, whatever the flow is there. Now, whenever you go for this network-based, so under this network-based intrusion detection system, you basically have some of the known attack vectors. So whenever I tell known attack let's say man in the middle attack is there, some kind of DOS attack is there. These all DOS attacks are basically whatever the data is there, whatever the pattern is there of that attack, that is automatical, that is already known by the network-based intrusion detection system. So based upon those patterns, it is going to look for the patterns which are present in our network. If the same pattern is being followed in our network also, then it is going to block the access based upon that data. Now, if we move forward to host-based intrusion detection system, guys, host-based intrusion detection system is nothing but whenever you go for a host-based IDS, you need to install each and some external software over the host's device so that the firewall can IDS can work properly. So here some external software requirement is there. That is the only difference. Remaining everything is same. The only thing is to use the host-based intrusion detection system. It basically secures your host, but one thing is you need to install some external software. That is the only difficult part. You can tell challenge. See, host-based intrusion detection system monitors an activity of an individual host, examines logs, file integrity. File integrity is nothing but related to the data, access authorization, and many another host-based data. It is completely intended towards the protecting the host and also to protect the host towards the unauthorized access. The only thing is disadvantage is it requires additional software agents to be installed on each host, which can impact the performance of the host. There is only one disadvantage you can find in HIDS. Now, guys, we got operating systems. I guess everyone know the basics about Windows operating system. So whenever you go for operating systems, we got two types of operating system, guys. One is Windows, one is Linux. Under Linux, we got Fedora, Red Hat, Ubuntu, CentOS. Different types of operating systems are there in Linux. But in Windows, we got only Windows Server and Windows Home operating systems. Now, whenever you go for Windows architectures and components, we got kernel, graphical user interface, file system, PowerShell, command prompt, and user access control. Whenever you go for kernel is going to be the core component which is going to manage the hardware resources of the system. So kernel's duty is basically to maintain the manage the hardware and also allot the hardware to each and every different application to basically use the hardware storage or to hardware processor or something. Graphical user interface is basically the part where whatever you see on the screen, right? Wherever you're trying to open a folder, close a folder, open application. So those all whatever you can see, that is basically the graphical user interface, which is used to basically build an interaction between the human being and a machine. File system is basically used to interact with the files. So whenever you want to extract a file, whenever you want to unzip a file, zip a file, compress a file, encrypt a file. So these all, whatever the activities are being done with the file, those basically comes under the file system. PowerShell or command prompt is nothing but, guys, each and every operating system has basically two different interfaces. One is user interface, and that is graphical user interface. Another interface is command line interface. Now, command line interface is nothing but where you're going to interact with the commands. You're going to give the command to delete, command to create, command to move the file, command to like edit a file, write a file, read a file. Those all you will basically do on the commands. But whenever you go for user interface, you're going to right click, you're going to delete, you have all the options there, right? You're going to use it in a user-friendly mode. So command line is basically completely it is basically completely intended towards the commands. If you know the right commands, you can use the command line interface. So majority of the Linux operating systems are command line interfaces only. So user access control. User access control is nothing but, guys, it basically deals with the authorization and access part. So to prevent the unauthorized access or any changes to the system, whenever you're creating admin, whenever you're creating the normal user or whatever profiles you're creating, so whatever the usernames or passwords are there, they basically comes under the User access control, you can tell. The way you are maintaining three different profiles on your computer. I hope everyone have seen your college laptops, college computers, where you have admin sign in and you have student sign in. Student sign in will have only access to few files, but admin will have access to all the files and all the configurations he can do. So the permissions are different, right? So for those permissions, to maintain that authorization, to maintain the access, we basically use user access control. Now, whenever you go for security features, guys, we have user access control 1, Windows Defender is going to be 1, and BitLocker is going to be 1. Whenever you go for user access control, we already discussed. Windows Defender is nothing but it has a firewall capabilities to basically block some infected websites access, to block, to automatically delete the infected files, something like that. And BitLocker is basically it encrypts the entire disk to protect your data. So you can encrypt it. And whenever you want to decrypt, you can decrypt the data and use it. That is basically BitLocker. So here in Linux operating system, we got different types of Linux operating systems. Ubuntu is there, Fedora is there, CentOS, Red Hat, Sushi, Debian, Linux Mint, Oracle, Gentoo. These are basically different operating systems. And in this, we basically got two customized operating systems which have inbuilt tools, softwares, and everything. Those operating systems are going to be Kali Linux and Parrot, which are basically going to be the customized Linux operating systems. So these are basically different types of operating systems. So whenever you go for architecture and components of Linux operating systems, so here also we got kernel, which basically manages the core system operations similar to Windows. User interface is there, which is basically the graphical user interface, which offers both command line interface and all. In here, in command line interface in Windows, you got PowerShell. Here in command line interface, you got something called as Bash. That one thing you need to concentrate. Again, file system is there. Under file system, commonly it basically uses ext4, known for its efficiency and reliability. Hierarchical directory structure starts from root. So whenever you go for accounts, guys, in this you basically got in Linux, you got normal user, you got super user. Super user is basically going to be the root. Normal user is going to be the normal login. So whenever you basically get root access, you can directly do whatever you want. You can upload, you can basically delete few directories, you can download without permissions or anything. If you're a normal user, then definitely you need to switch to the root part. So root is basically having different user ID and password. Normal account is also having a different ID and different password. So here there are basically some standard directories /var, /home, /etc. So these are basically inbuilt directories, guys, where your data is being saved. So these directories cannot be deleted. These directories cannot be updated. These are by default directories. This automatically store the required data. This automatically delete the unrequired data. So common features and tools. Package management is there. Uses package managers. So these package managers are basically used to install few of the applications, few of the requirements, update the present operating system to some next level of operating system, or to manage different softwares which requires regular updates and which requires regular, you can tell, additional libraries to be implemented. So for that, we use apt for Ubuntu and Debian, yum for DNF for Fedora and Red Hat. These are basically three different package managers used for Fedora, Red Hat, Ubuntu, and Debian. Four operating systems basically work on these packages. So these packages help them to download the required packages, which basically help them to keep updated the operating system. Now we got something called as shell. So shell is nothing but, guys, the terminal is basically a powerful tool performing wide range of tasks. using CLI. So shell is also similar to command line. It is basically a command line interface. So in command line interface, you can perform based upon the commands. Whatever the actions you are performing, whatever you are trying to upload, download, or whatever the actions you are being taken, you will perform through using commands. In Linux, let's say you want to create a file, create a folder. The folder is technically named in Linux as directory. If you basically want to create a directory, you are going to use mk directory, make directory, the directory will be created. If you want to create a text file, then there is another command. If you want to read a file, then there is another command. Delete a file, another command. Permissions, chmod. Like the different sorry guys. So like the different you got different commands for different operations. So whatever you want to do, you will basically complete them on a command line interface itself rather than going for a user interface. Yes. So guys, in Linux, whenever you go for the security features, whenever you go for file permit, security features and security, so here, whenever you go for the file permissions, guys, here also you basically have some kind of control access. In Windows, we got user control access. So here we got control access over files and directories. So you can basically keep an authorization for different folders, different files. And here we got firewalls. So there we got Windows Defender. Here directly we got a firewall where we can set up the network security by using rules and rule tables, as we already know. And one more thing, whenever you go for the security vulnerabilities, so whenever you go for the vulnerabilities in Linux operating systems, guys, so here we got something called as patch management. What is exactly patch management? So whenever you get a vulnerability in one of the older version, in present version, so automatically you will be getting a new version to download so that vulnerability is resolved in the new version. So resolving the vulnerabilities and giving a stable update to the operating system, so the vulnerabilities will be resolved and security will be enhanced. So what will exactly happen is, let's say in the present version, if you have some vulnerability, some kind of flaw, some kind of security threat, so that particular threat, that particular vulnerability, that particular flaw will be basically removed by releasing a next version with that patch. So whatever vulnerability is there, I have already downloaded the operating system, I updated it. So I have the vulnerability. Now again, if I want to remove that vulnerability, I need another update with no vulnerability. So basically, whenever I try to update my software, whenever I try to update my operating system, then that vulnerability will be patched from the operating system side. That is the Linux side or Microsoft side, who basically owns the operating system. So whenever you go for performance and stability, guys, so Linux is basically preferred for more performance. So whenever you go for servers and whenever you go for the Windows is basically used for desktops and enterprises. So the reason why we use Windows more in our laptops is because the reason is Windows has a good user interface. But whenever you go for Linux, Linux has good command line interface. So Windows ability is to provide a good user interface, that is GUI, and Linux ability is to provide a powerful command line interface, that is bash. So there are basically two different. Whenever you go for Linux, it is basically used in the servers. It is basically used in the servers. And whenever you go for Windows, it is basically used for the desktops and enterprises. And those are basically two different parts. Now, whenever you go for Linux type accounts, as I told, one is the root user, one is the command line user. Command line user use the user commands like user mod, address, delete user. Add user is basically add user command. Delete user is basically del user command. So these commands are basically used to manage the user accounts. Whenever you go for root user, it is basically considered as a super user who have the complete access over the operating system. He can perform whatever he wants. Now guys, whenever you go for Windows vulnerabilities and Linux vulnerabilities, Privilege escalation is there. Under privilege escalation, we basically what we'll do is whenever you go for access control list, that is user ID and password. The reason why we tell that weak ACL is because whenever you have some unsecured user IDs and passwords, that is you don't use the password properly. So whatever your password is there, if it is actually weak, then it is going to create a weak access control list. So SMB protocol, server message protocol, is basically used whenever your remote code execution attacks have been done. So if you basically have server message protocol, this server message protocol is open, SMB protocol is open, whatever the port number is there, if that port number is open, then definitely it is vulnerable. Delayed update. So as I told you, whenever we basically try to find a vulnerability in an operating system, if the update is being delayed till the vulnerability being resolved, we will still face that vulnerability. So that is basically the risky part. Now we have something called as malware. So I guess everyone know what is malware exactly. So it is basically a malicious code which can be executed on its own. So once you download a malware, then the code is executed and the attacker is going to get the remote access connection to your computer over the internet. So phishing is one where users are targeted over the links. We have a case study of eBay as we discussed in the first class, the 140 million data breach by using the employees, 3 employees user credentials itself. That was a phishing attack, which was basically created over the user IDs and passwords login portal. So we got RDP vulnerability, remote desktop vulnerability, which allows the hackers to access your computer or access your laptop or whatever your device is remotely. So RDP basically operates on port number. So that basically port number, if that port is basically open, then anyone over the internet can access your computer remotely. That is a part. So RDP vulnerability is basically it will be open. Whenever the RDP port is open, then we can tell that RDP vulnerability is there. If you don't use the right rules, if you don't use something like Windows Defender or Firewall in the Linux operating system, then definitely you have a vulnerability for RDP. So remote connection is possible. So under Linux vulnerabilities, guys, same thing, privilege escalation is there. So which is basically done over the user IDs and passwords. Open ports are there, which are basically vulnerabilities to build the connections from the backdoor, unpatched software updates, kernel updates, weak passwords, and SSH vulnerability. So these are basically all known vulnerabilities. We already discussed weak passwords, kernel updates. So whenever an update is being delayed, automatically your operating system is being vulnerable. That is the thing. Now, guys, whenever you go for footprinting and reconnaissance, sir, we are getting invalid register when we entering our college roll number in project registration. Tomorrow is the last date for the registration. Okay, I just make sure this will be taken care of. Farman, can you please post your roll number here, Himaja, in the chat box itself? Guys, whoever is facing the problem, they can basically post their roll number here in the group chat. Who are basically facing the invalid registration project selection link are posted on Telegram. Student can select the suitable projects. Okay. Still anyone getting some invalid registration or something like that? Guys, the project link is being shared in the Telegram group. So you can go there and you can pick your own projects, whatever are suitable for you. Just try to check with the Telegram group. Okay, guys, we got something called as footprinting and reconnaissance, which basically comes under the information gathering. Second part, information gathering, footprinting, scanning, gaining access, maintaining access, and clearing tracks. So under footprinting and reconnaissance, we are basically going to target information gathering targets. We basically have two different targets. One is organization and one is person. Small information about web vulnerability scanner. So guys, whenever you go for web vulnerability scanner, you can either use Metasploit, you can either use Nikto, and you can use any of the open source vulnerability scanners. So you can just go to Google and type open source vulnerability scanners. You can clone them and you can perform multiple scans over. Nmap is not a vulnerability scanner. Nmap is only network scanner. So vulnerability scanner is going to be Nikto is one. Burp suit, some extent you can tell burp suit. Try to search on Google or somewhere. You will get the list of names of open source vulnerability scanners. Try to clone them using GitHub repositories. Clone the GitHub repo, and you can use the tool, and you can perform it over DVW. You can also perform the scan over Aquitics vulnerable website. So there is something called as OneWeb. Yeah, OneWeb. You can go there and you can perform the vulnerability scan. You will get all the details. You can use that link, guys. So here, guys, whenever you go for information gathering part, we have two different targets. One is organization, one is a normal person. And whenever you go for ways of information gathering, one is active way, one is passive way. So under active way, we basically discussed that it is going to involve the interaction with the target. So if you're directly interacting with the target and trying to gather the information, it is an active way. Now in passive way, you are not interacting with the person directly. You are using the resources from the back end, like either interacting using the social media or any of the online resources which are publicly available, or privately also you're trying to access and get the data. That is going to be the passive way. Under active way, you are not allowing the user, you are basically interacting the user, you are exposing yourself. In passive way, you are basically maintaining the privacy of your identity, and then you are trying to gather the information. So we got two different ways. Now here, we basically discussed the target, that is organization. First, we discussed the target about the organization. Whenever you target the organization, guys, so here we discuss something about the search engines, right? The safest search engine is DuckDuckGo, and one of the powerful search engine is a Chinese search engine which is named as Baidu. So they are basically two different search engines. Now, if you basically want to go for Amazon, let's think the target is basically Amazon. We are targeting an organization. The organization name is Amazon. Now, whenever there is basically Amazon involved, there is one thing in common, that each and every company has domains. Whenever you basically look at the companies or any of the organizations online presence, it basically depends on the domains. So in these domains, we got two types of domains are there. One is major domain and one is subdomain. One is major domain and one is subdomain. So major domain is always basically considered as the highest security one. And whenever you go for the subdomain, these subdomains doesn't have that much security as compared to the major domain. So major domain is basically a domain where the whole face of the company, that is the main website, functions. But subdomains like amazon.delivery.com, amazon.sellers.com, amazon dot you can tell blog.com. These are basically domains which basically work on the some limited operations. So for that, basically we use a tool called as sublister. Here you got, if you want to go for the domain names information, something is basically who is lookup is there, and sublister is there. They are basically two different tools. So sublister basically takes the help of multiple search engines at single time to gather more information. And amazon.com will directly go for the number of domains which are basically available. So two different tools are there. Let me just go for the part 3 once. Sublister, yeah. Here you can see who is amazon.com, and I'll just show you this. Sir, can you explain about project brief? Guys, you basically got the link to select the project, right? You can basically use that link and you can gather the information, whatever information you find on the internet. Try to do some research, try to do, and there are basically a list of 25 projects. Try to see which project you're capable and which topic you are able to, which topic you're comfortable, and then try to complete it. First, try to finalize your topic first. Okay, guys, we'll stop till here today. So tomorrow we are going to, in the next class, we'll be basically discussing, we'll continue this part. Once we complete the sublister and Maltigo tool, then directly we'll discuss about the scanning and then we will move forward. Okay, we still have scanning using Nmap, Maltigo for information gathering, and sublister is there. Who is lookup is there. Sublister is there. Who is lookup is there. Maltigo is there. And after Maltigo, we basically got another tool here. Nmap. After Nmap, we'll be briefly discuss about enumeration part. And then DNS enumeration is there. Vulnerability assessment is there. And then we will close all the topics. Then we can move towards the another section. Should we complete all the texts by tomorrow? I am sharing Google spreadsheet. Students who are facing problems, they can write names in that. Sir, yesterday I gave this link, but this is not opening, sir. I can open it, right? Look at the screen. It is opening. Enter the roll number. Tell me your roll number. What is your roll number? 228. I'll just type this. 228 T1. 228 T1 A0 460. Next. Anil, what happened? I am getting everything here. Confirm your details. I confirmed. Which project do you want, Anil? Tell me. I'll only choose. Anil, are you there? 1808952. Guys, I am again telling you, don't do silly mistakes. See, I am getting everything access. You are telling I am not getting access to projects and all everything. What is this? You need to be check your internet connection and all. Try to access the website using a laptop if you're not able to look into the message. And there was one more roll number who was facing the issue, right? 218 T1A. I'll also try to enter T1A 04E1. E1. Sheikh Hussein. What? 21. Okay, 1 second. 218 T1A 04E1. See, guys, Maheshwari, I'm also getting your access here. Which project you want? Tell me, I'll choose. Maheshwari Tripathi. If you tell, I can choose it here also, here itself. And also there was another number, right? There was some another number, 209 F1A. 209 F1A 0563. Guys, I am getting each and every person's name, details, everything. Please try to select the project and finalize your projects. Farman, I guess there are no errors. There is no need of any Google sheet or anything. They are not facing any problems. They're just not trying to fill the form. Guys, try to fill the form, try to select your project. So that's it for today, guys. Here you have some students who are facing the problem. They can basically fill this Google sheet here. Fill this Google form. Internship last date when we submit the project. You will get to know the information. You will get that information.